Hey everyone, let's solve the third question from today's weekly contest. That is minimum number of operations to sort a binary tree by level. You are given the root of a binary tree with unique values, and in one operation you can choose any two nodes at the same level and swap their values. Return the minimum number of operations needed to make the values at each level sorted in a strictly increasing order, and the level of a node is the number of edges along the path between it and the root node. So basically in this question what we are given is a binary tree, and we have to traverse that binary tree level wise, and for each level we have to sort that level, right? So how we can sort that level is we can perform an operation. What that operation is, we can choose any two nodes of our choice and we can swap them, right? And performing these operations we have to sort every level in strictly increasing order, and what we have to return is the minimum number of operations we need to do so, right? So let's see it with an example. So this is what we are given. So this is the first level of the tree, right? So we have 4 and 3 here. So what we can do is we can swap them, right? If we swap them we will get 3 and 4, right? So this is our first swap. Then this is our second level. So at second level we have 7, 6, 8 and 5. So how many swaps can we do to convert it in a sorted order, right? So let's say we swap 5 and 8, right? So if we swap 5 and 8, we will get 5 here and we will get 8 here, and 7 and 6 are here only, right? So that is one swap. Then what we can do is we can swap 7 and 5, right? We can swap 7 and 5, so we'll get 5, 6, 7, 8, right? So it is now sorted. So the minimum swaps that we required for sorting this particular level was 2, right? 5, 6, 7, 8, right? So minimum number of swaps are 2. It is already sorted, so we don't have to do anything, right? So the minimum number of swaps required to convert this binary tree in a sorted order is 3, right? So now let's see how we can do this, right? How can we calculate it? So basically first what we have to do is we have to traverse it level wise, that is BFS, right? So after we apply BFS for each level, what we can do is we can store it inside of a vector, right? So after we store it in a array or a vector, right? So now the problem reduces to minimum number of swaps, right? How many swaps, right? We have to just calculate the minimum number of swaps to sort a particular array, right? So it becomes this question now. So what we basically have now is we have an array, right? We have an array and we have to sort it. How we have to sort it? We have to just calculate the minimum swaps to sort it. So let's see how the algorithm for this works. So what we can do is we can create a vector of pairs, right? We will create a vector of pairs, right? So what we can do is, so let's take this level, right? So let's say we stored it inside of an array. Now let's create a vector of pair. Will be associated with their positions they are at currently, right? So what we will get is 7, 0. All right, then we will get 6, 1. Then we will have 8, 2, right? And then we will have 5, 3. Now what we basically are saying is we have created our pair, right? Now what we are saying is let's sort this pair, right? So if we sort this pair, what we'll get? We'll get 5, 3, all right? We'll get 6, 1. This will be 7, 0, right? Will be 7, 0, and this will be 8, 2. All right, this is 8, 2. Now we have sorted this pair. Now what we are saying is, to calculate the minimum swaps, to calculate the number of swaps, we will go back from this to this, right? We will go back from our sorted array to the array that we had, right? And we will check the number of swaps. Now what we will do is we have to just check for the current positions, right? So as you can see, the 5 comma 3 is here, but in the original array it was at the last position. So what we can do is we can swap these two positions, right? So if we swap these two positions, what we will get? We will get 8 comma 2. We'll get 8 comma 2 here. We'll get 8 comma 2 here, right? And we will have 5 comma 3 right here. Okay, we'll have 5 comma 3 here. Now this is one swap, so let's put it inside our count variable, right? So number of swaps inside this variable. So right now it's 1 because we swapped these two. Now let's again check. So as you can see, these two are at the 6 is at its position, right? So we will do no swaps here. Now we'll come here, right? 7 comma 0. So it's not at its position. So what we have to do, we have to swap 7 comma 0 with the first position, because it is in the original array, it is at the first position, right? So we will swap 7 comma 0 with the first position, right? So what we will get? We will get our original array back, right? We will get our original array back after doing this operation. So now the count is 2 and this level is sorted. So that is how we have to calculate the minimum number of swaps. So let's see the code of it. Let's see the code part. So what we are doing is, here we are traversing level wise, right? Inside this while loop, we are traversing, just a minute. Okay, inside this while loop, we are traversing level wise. And for each level, we are calculating this vector v, right? We're calculating this vector v and we are storing the particular nodes in that level inside of this vector. So after we have, stored all the nodes inside of a particular level inside this vector, we are creating this vector of pair, as we saw in the algorithm, right? We are creating this vector of pair and we are just putting associating the values of nodes with their positions in that particular level. So that is what we have done here, and then we are sorting this, right? We are sorting this pair, and then inside of this loop we are actually performing the swaps, right? So we are checking if the position matches to the position as in the vector, then we will just continue, right? Else what we have to do, we have taken this count variable to calculate the number of swaps, we have to increment it and we have to swap that particular element, right? And then after each iteration we are adding it to our answer variable, like the count for that particular level, and we are returning answer.